Hey everyone, welcome to our Data Umbrella webinar for December 2021. Next slide. So the agenda is I'm going to do a brief introduction about less than 5 minutes, then Ian is going to do his talk, and then we'll open it up for Q&A. Today, because we are using Zoom for the first time, if you want to ask a question and share your mic and or your video, you can. If you don't, that's fine. You can post your question in the chat and we will read the questions and answer them at the end. Okay, next slide. Data Umbrella is a community for underrepresented persons in data science, and we are a nonprofit fiscally hosted by Open Collective. Okay. Next slide. About me, I'm a statistician data scientist, and you can find me on Twitter, LinkedIn, and GitHub at @ReshmaS. We have a code of conduct. We want to provide a welcoming and friendly and professional space. So please be mindful of that. And we encourage any questions on the chat, but the code of conduct also applies to the chat. Next slide. There are various ways that you can support Data Umbrella. The first and foremost is to follow our code of conduct. And another way is you can join our Discord and ask or answer any questions there. You can share events or job postings. And the link to Discord is on our website. Next slide. Another way that you can support Data Umbrella is to donate to our Open Collective. And it is at opencollective.com/data-umbrella. If you work for a corporation that uses the Benevity platform, what that does is you can make a donation and your employer matches it. And then that donation is transferred over to Open Collective. And so the link to that is causes.benevity.org/projects/416826. And I will share some links in the chat as soon as I'm finished presenting this. Next slide, please. We have a lot of videos on YouTube. We've been doing webinars online since the start of the pandemic, actually. And so one of the video libraries is contributing to open source, and we have presentations on NumPy, Pandas, Core Python, scikit-learn, so check it out. Next slide, please. We also have a library on career advice, and we've had 4 really phenomenal women speak about career and ways to navigate some situations, and I definitely recommend checking those out. Next slide, please. And this is just a sampling of some of our videos. Next slide, please. We also have a job board. It's jobs.dataumbrella.org. Feel free to check out the job postings. You can share any postings for free if your company is hiring, or you can check it out if you are looking for positions. Next slide, please. Our website, which is dataumbrella.org, has a lot of resources on it for upcoming conferences, open source, guides to using inclusive language, accessibility, responsibility, AI ethics. So we definitely encourage you to check that out. Next slide, please. We're on all social media platforms as Data Umbrella. The ones that I've highlighted are the ones that we're the most active on. So there's Twitter at Data Umbrella, LinkedIn at Data Umbrella. The best place to find out about upcoming events is on our Meetup group, and that is also as Data Umbrella. This is being recorded and we will put it on our YouTube, and I will share a link to that in the chat as well. We also have a monthly newsletter that goes out, so you can subscribe to it to get updates as well. Next slide, please. Our next event is, so today's Tuesday, next Thursday on December 16th, the webinar is on Plumber, which is a maintainable and collaborative pipelines in Jupyter. And we will soon be posting that event on Meetup. Next, please. Today's talk is R, an ecosystem where Pythonistas can thrive. I'm really excited about this. It's been in the planning stages for a few months, and I'm happy to have an event where R and Python are connected. Next slide, please. So today's speaker I want to introduce is Ian Flores Siaca. Ian is a data person with a background in data science and DevOps. He has experience consulting within the pharmaceutical industry, the government sector, NGOs, which are non-government organizations, and educational institutions in multiple countries. As part of his academic background, he holds a master's degree in data science from the University of British Columbia in Canada. And outside of work, he's a certified free diver, loves to surf in the northeast corner of Puerto Rico, and cooks spicy food. You can find Ian on LinkedIn and Twitter and GitHub at Ian Flores Siaca. And with that, I will turn the mic over to Ian. And if you have any questions, just a reminder to post them in the chat.
All right, sounds good. Let's get started. So, hi, as Roshana said, my name is Ian Flores Siaca. My pronouns are he, him. And today we're going to be talking about R, specifically how it's an ecosystem in which Pythonistas can thrive. So first, let's do a brief round of introductions, or a brief introduction of me. I'm a solutions engineer at RStudio. RStudio is a company that develops data science software. And I work as a solutions engineer, helping clients set up their environments and so on.
Sorry to interrupt, but your mic isn't very clear. There's like a shaky thing, and I was just wondering if there's something that you could do just to make the sound clear.
Yeah, give me 1 second. Is it better now?
Can you keep speaking?
Yeah.
I would say this is better. Yes, thank you.
Okay. Yeah. So I'll just get started again. So yeah, I'm a solutions engineer at RStudio. RStudio is a company that develops data science software for different companies and for different purposes. It develops both software for R and for Python. So that's a little bit of what we're going to be talking today. As part of my background, I have a master's in data science from the University of British Columbia. I'm Puerto Rican, born and raised here on the island. And as personal stuff, I love bodyboarding, and I'm a certified freediver. You can see me here in the water in this picture. As part of my professional interest, I like to focus on data science infrastructure and on DevOps practices. Specifically, I like to merge both of these with cloud engineering to sort of think and implement and deploy different workflows that allow folks to reduce the friction between data scientists and their sysadmins, that also allow them to do quick work and follow best practices. So yeah, that's it about me. Now about today's talk. We've already covered a little bit of this brief introduction. This is the second part. Then we're going to be talking about sharing data with computers. After that, we're going to be talking about sharing data with humans, later followed by R tools that I believe Pythonistas should know about when they're trying to dive into the language. And lastly, we're going to close with a case study about a bilingual data pipeline, how that can look and how you can implement one. And I sort of added an exercise at the end so that if you want to take the pipeline that I created and sort of expand it because you want to test your R or your Python skills, that you can also do so. One thing I want to make clear of this presentation is that I didn't want to make a presentation that was just, hey, this is R, this is how you do a for loop in R, or these are the main packages in R that you would use and so on. I wanted to make a presentation that would sort of present to you how you can incorporate R and Python and how you can incorporate certain things that you follow in Python, like using classes, like using virtual environments, and how you can do those same things in R so that when you decide to start diving into the R world, you have the tools to do so without going too far away from what you already know, and that you can do knowledge transfer in that part. So with that being said, let's get started with the first part, which is sharing data with computers. We usually talk about sharing data, and we talk it mostly in the context of sharing data with people, but that's not actually true. We usually don't share data with people. We share data with the computers of those people, and they use those computers to interact with the data. And this is very important because sometimes we think about different data formats or so on that we want to be able to see the data, but that might not be the most effective way to access it or the most secure one. And those are the sort of topics that we're going to be covering in this section. So to cover this topic about sharing data with computers, there are three main ways that I like to think about sharing data and three types that you can share data. One is web APIs, the other one is cloud storage, and the third one is databases. And we're going to cover them in order, and what I think it's important to know, at least as a primer, in those different areas. So let's get started with web APIs. Web APIs have two main purposes from the perspective of a data professional, be it a data scientist or a data engineer. And it's that they can access data and serve data. So if you want to access data, let's say from the Twitter API, you would use the REST API to perform GET requests and get that data into your environment. Now, you can also use them to serve data. And that is, I have some data that I want to make available to some users, be it because I have some application or I have a database that has this data and I want to expose it to those users. I can also use a web API. Now, the way that web APIs work is that you have a user or you have an application, which is this person here on the left, and they perform a request. In this case, it's a request of type GET, but it can be a request of type POST, for example, if you want to send data to the server. But in this case, it's of type GET. So you perform your request, and then that service, that API, it's going to return to you an answer. In this case, it's saying, hey, you should buy Apple stock. But it can say other things, like you can literally code an API to return any type of data back. Now, from the perspective of a data professional, you can end up having to support both accessing and serving data, because you can end up having one API, like let's say a Flask API, that it's serving some type of data. And then you have a dashboard that it's a shiny dashboard that it's reading that data. And in that case, you have to think both about how do I serve this data in a way that I can use it later in my application, but also how do I receive this data and handle it, the application in a way that it's efficient for the whole process. Now, web APIs introduce a little bit of complexity with sharing data in terms of security. You have to share usually an API key if you want to make an authenticated request, and that introduces things like credential rotation and so on. Like, how do you manage this credential? How do you make sure that it's not exposed, etc., in your code? So those are all things that have to be considered when working with APIs, and the fact that they require some level of structured data, because you cannot have just, the API will return a very specific thing, what it's coded to return. It's not going to return any type of thing just randomly. So yeah, those are things to take into consideration with web APIs. Now, how does it look to access data from an API using Python? There's two main libraries to do this in Python. There's urllib3 and there's the request package. I personally like to use request more, but it's not like they literally have the more or less the same amount of downloads from PyPI, which is the Python package repository. So they're more or less use the same. Now, I like to use request more just because I got started with it first. And to access data with requests, you would import the package as you do with regular Python packages, and then you would perform your request. So request equal request.get, and in this case, we're hitting the API from GitHub, and we're hitting the events endpoint. So in this case, we want to see what's there, what's available. It doesn't require any authentication or anything, so we're just getting data. We transform that data into a JSON object, which essentially what this function does is it takes the JSON that was returned from the server and it transforms it into a Python dictionary so that you can use it later for examination or for your data analytics purposes. Now, you go ahead and you print the event, and you can see all of the data that was stored there. In this case, it's a push event. So imagine that I push something to my GitHub repository, and you can see my information, Ian Flores, my display login, and so on, that of the thing that was pushed to the repository. So this is how you would access data. You can imagine this, as I said, accessing the Twitter API or accessing other APIs, like the Salesforce API, for example. Now, how does it look to serve data with APIs using Python? And I'm showing you this because I want you to see how similar it is to doing things in R, and that it's really translatable to change from one language to the other, even if there are things that are more idiomatic in one than the other. So with Python, you can serve data using both Flask and FastAPI. Flask is sort of a little bit older, but it's commonly used and a lot of frameworks still support it. FastAPI, it's more newer, and I keep seeing it more frequently being used in deployments and in people that are starting new projects. If they have to choose a package that they want to use to serve data with Python, they tend to go with FastAPI and not Flask more recently. So with FastAPI, you just have to have one file, like that main file. It can be called whatever, but it needs to have a main file. And you import the package and you create an app. And you say, hey, my app, it's going to be a FastAPI. And then you define your endpoint. In this case, what we're saying is I want to define an endpoint that it's at the echo endpoint, so like at the echo path. And what that does is anytime it receives something, it's just going to return that same thing back. So if you send a message to this API, it's just going to return that message back with this added text that said, this is the message. So this is using an F string, and it will parse it and insert the message here within the brackets. Now, to run this API, you just got to do ubicorn main app and reload so that the application keeps running by itself with this ubicorn server. Now, when we look at how to do this with R, it's fairly similar. You have a high-level implementation, which is HTTR2, which is the one that I'm going to show you here on how do you use it to make a request to APIs. But there's also a low-level implementation, which is called the curl package. And the curl package is literally an implementation of the curl Linux utility in the R language, so that you can use it to make those low-level requests if you want. But usually when we're dealing with APIs and a little bit more structured things, we would like to use something like HTTR2. So you import the package, library HTTR2, and then the difference with HTTR2 is that it doesn't perform the request. So you can build a request and add everything that you want to add into the request, be it headers, be it the user agent, for example, things like that, without having to actually perform the request. And that's actually nice when you're doing testing with services that might be fragile, because you don't want to overload them until you've got your request structure out properly. Then you do request perform. And what that does, it's literally performing the request. So once you've built it out, it's gonna actually do the request. And if it's a GET request, which is the one that it's done by default, it's gonna return to you what is the response from the server. And in this case, I'm printing it here, and you can see that we performed a GET request to the R project page. And we can see that the server returned a 200 OK status. And we can see that it returned a type text HTML, even though we were saying that our application only accepted application JSON. And we can see that the object that it returned, it's 6,085 bytes, and that it's saved right now in memory. It's not saved anywhere else, like in a file or anything like that. So yeah, this is how you would access data from APIs using R. It's fairly similar to how you do it in Python. Now, to serve data with APIs using R, there's not as many options or variety as there is with the Python, but there is a package that it's very robust in the way that it works to serve APIs with R, and it's called Plumber. To define an API endpoint Plumber, it's very easy. You just define a file called plumber.r. You can name it however you want. And with these comments added in the code, you specify, hey, this function is gonna receive a message parameter, and that's the message to echo. And in this case, we're defining the same API that we define with FastAPI, but just with Plumber. And we're saying this will receive only GET requests at this endpoint, which is the echo endpoint. And this is the function that it's gonna manage that. So it's gonna return this list that has this message, which is the message is and the actual message. So this is how you define the endpoint. Once that you have that file, to run it, you just have to specify library plumber, and you specify the file in which the Plumber API lives, and you run it with a specific port. This is quite useful because if you want to specify this port as an environment variable, and sort of control everything in match through a Docker file, for example, you can do so here by reading an environment variable and that way running the API. Now, the nice thing about Plumber APIs is that they generate this documentation page automatically. So the server will always be running at the server address and a specific port number that you specify. If you're doing local development, so like in your own computer, that server address is going to be the local host address, so 1.7.0.0.1, and then the specific port number that you specify. Now, these docs will live at that address, but at the __docs__ endpoint. So if you want to access the documentation for your API, you would go to that address and see all of the documentation. This page is quite nice because it also allows you to test the function, so that you can send test arguments to the function and to the API endpoint within this page without actually having to write more code to test it. So that's it with APIs. Now you know how to access data both with Python and with R, and how to serve data with Python and R. You know a little bit about the considerations that need to be made when using a web API in terms of security and the structure of the data. Now let's talk more about cloud storage. Cloud storage, as you might know it, it's S3 buckets, Azure buckets, things like that are mainly blob storage, places to store blob data. Now, cloud storage has some advantages and some disadvantages in terms of security, in terms of network and organization. And I'm gonna go over them now. So in terms of security, cloud storage enables you to use ACLs, which are access control lists, and those allow you to specify which specific files users have access to. And that is quite useful because you might say, hey, data scientists have access to all the server, but the marketing analysts only need access to the marketing data. So I'm only gonna give them access to that folder instead of the whole bucket where all of the data is living. Now, that also means that that bucket can be exposed if it's not properly configured. And that has happened before. A lot of the data breaches that we see in companies is because they simply didn't configure their bucket correctly. So they exposed a credential that had more access than it needed to, or they made the bucket publicly, unknowingly, although it's quite hard to do it unknowingly, but yeah, it happens sometimes. So yeah, those are the considerations to be made when using cloud storage. Usually, this is not the responsibility of the data scientist or the data analyst, but it might end up being, depending on the company. So you just have to be aware of those things in case they come up. 1 second. All right. So the other consideration is in terms of network. Usually putting data inside of cloud storage is free. Companies won't charge you for it, but they will charge you for getting the data out of the bucket, even if it's within their same infrastructure. So those are things to consider. If you're using things like an EC2 instance and you have an S3 bucket, you can enable things like peering so that you can access that bucket more easily and it doesn't incur in as many charges. But there's still that network access of having to get them from the S3 bucket and download them into the local environment. Now, the other thing about cloud storage is that it usually organized in tiers. And this mostly concerns folks that are more in the data engineering side of things, but it might end up as well affecting folks that are more in the data science. So cloud storage is usually organized into 5 different stages or tiers. The first one is landing. And this is if, for example, you're thinking of doing web scraping. You would want to first download the whole page and store it in the landing zone. Then you would want to have data on staging, and this is data that it's ready to be processed, be it by your data processing scripts or other software. And then you have production, which is the data that it's ready to be used, be it by the data warehouse, be it by other folks like the data scientists and so on. And this data has been already being manipulated in some ways to structure it a little bit. And then there's the archive and the failed data, which are just where you store the old data and where you store things that might have failed in certain pipelines. But we're usually concerned with production when we want to do things like machine learning, when we want to do things like data analysis and so on, because it's data that it's not yet still in the warehouse. So it's not necessarily being totally reduced to a very structured architecture. but it might still contain some raw data that might be useful for doing the work that needs to be done. Now, when we're talking about cloud storage, there are many different formats in which you can store. You can literally store in any format in the cloud. But the most common formats that I see around data science work are JSON, YAML, and I added asterisk CSV, but those are all of the delimited files are like comma CSV, tab CSV, etc. So yeah, these are just the most common formats that I see and in which folks usually store their data in cloud storage. Now, these types of files tend to get very big as you have more and more data. And that gets a little bit tricky to manage. You can use things like there's AWS services, for example, to use SQL queries to query your S3 bucket. But those things get a little bit complicated and they're not optimal all of the time. So if you want to save a little bit on storage because you want to do things a little bit like analysis in your own computer or things like that, you can use binary formats. And binary formats for data are something that it's a little bit tricky to manage. And you've got to give it a little bit of consideration when designing your pipeline. So you shouldn't use pickles, which is like the binary format for Python, and you shouldn't use RDS, which is the binary format for R. And that is because this, as I said, these are the binary formats for specific languages, but they don't allow you to share data as easily across environments. So if you have a pickle, it's a little bit hard to read into R without using external dependencies. Or if you have an RDS, the same in Python. And some of the times it's not even possible to deserialize. So there tend to be some compatibility issues there. Now, what it's recommended is to use binary formats like Parquet, like Feather, and like Avro. And which one you use, it's going to vary on your necessities. So for example, Parquet, it's optimized to store data columnarly. So it stores data in a column-oriented way. What that means is that if you got to perform a lot of summary statistic on a specific column or things like that, Parquet is going to be more efficient to you than, for example, Avro, which is row-oriented. And what that means is that it stores the information more optimized to be accessed in a row. So if you've got to access the data, like the whole row to get your data, then Avro might be a better approach for that. Now, Feather is another format that it stores tabular data and it compresses it to really, really small sizes. So yeah, these are all just different formats that you can use to store your data. As I said, you've got to give it a little bit of consideration to which one you're going to use in your pipeline. Now, lastly, I want to talk about databases. And databases are a little bit of a topic that's been with us since almost forever in computing, but at the same time, it's a little bit foreign to most people in the tech area. So databases are quite nice because they provide a common interface with SQL. So if you're using a relational database that has a SQL engine, this is a diagram that I got from my company, RStudio. But this is usually how a database would perform. You would have your database, and that would have a SQL engine, and you would have your tables and your views and so on. Your SQL engine is where it receives the SQL queries to then access the tables and so on. And that's quite nice because if you have a SQL engine, that means that I have a unified language that I can use across different databases to access data, do joins, etc. In practice, most database providers tend to implement a little bit of certain things that are idiomatic to their own specific database, but most of the time, a SQL query is a SQL query and it will work out of the box. Now, with databases, there's also security considerations to be made. You can share very specific access to databases. So there are databases that, for example, support row-level security and row-level access. And what that means is that you can specify that a specific user or a member of a group can only access certain rows and not all of the rows in the database. And that's quite useful because it allows you to be very granular in how you set things up. Now, that also means that the same with Cloud Buckets, it's a little bit hard to handle all of those security considerations. So it's usually quite handy to have someone that can help you, like a security engineer and so on. Now, from the perspective of R and from the perspective of Python, you use a package to access that data. from those databases. And that package mainly acts as an interface to a database driver that it's the one that is going to be making the talking to your SQL engine. So in R, that package is called odbc. And in Python, it's called pyodbc. And essentially what they do is they do that translation to a database driver so that you can talk with the SQL engine. And yeah, the last thing to know about databases is that you've got to make architecture considerations. So if you want to put your data into a database, you've all got to already know what's the structure that it's going to have, how do you want to store it, which are the tables that are going to go, and so on. So all of that schema needs consideration and architecture considerations need to be done beforehand you start using the database, because doing migrations and adding things into databases gets a little bit complicated as the database grows. Now, let's talk about sharing data with humans. We got now a primer of how to access a bunch of data from AWS, how to access a bunch of data from the different cloud providers, from the buckets, from APIs, from databases. So how do we share this data with humans? Like now we want to share data with humans. But hey, Ian, didn't you say that we don't share data with humans? Like we share them with computers? And that's right, we don't share data with humans. We most of the time are sharing insights with humans. And that's what most people are interested in. They're not actually interested in the data, even though everyone keeps saying recently that data is like oil or data is like gold. It's like most people aren't actually interested in the raw data. They're not going to do much with it. They're more interested in the insights from the data. So how do we share that in those insights with the humans that are going to be consuming them? So I want to walk you through sort of some tools in R that are useful for this and that you can also incorporate with Python to make your life easier in this domain. So RMarkdown is the first one. RMarkdown is quite nice because it allows you to define here a YAML header within one same document. And you specify, hey, this is the title, the author, which in this case is me, the date, and the output. I want this to be an HTML page. And the way that you define which language you're going to be working with, is you specify here if you want to use R or if you want to use Python. You can also use SQL, and there's other engines that you can use. Apologies. There's other engines that you can use with Knitr, which is the engine that knits this document. So that's the process of building it from the RMarkdown document into the output that we specify here. And the nice thing about RMarkdown is that you can have one chunk here that it's with R, and you can have the next one with Python. And that's using a package called Reticulate that we're going to look a little bit further in the presentation. So you can add regular Markdown like this header here. You can specify, hey, this is a second level header, RMarkdown, this is regular text, and just have your whole document laid out that way. This is quite nice because RMarkdown is very extensible. There's the downverse, what I like to call the downverse. And what the downverse is this set of packages. There are other packages as well from the community that allow you to use RMarkdown to build different things. So package down will use your comments in your, it will use your comments in your function definitions when you're doing a package, and it will auto-generate documentation for you so that you can access that. Now, it's nice because it also allows you to use RMarkdown to add articles and vignettes so that folks can better orient themselves on how to use your package. There's also bookdown and blogdown, which are, as their name suggests, allow you to write books and blogs, like web pages, with using RMarkdown. So it's very extensible in that way, but it's also extensible through other ways that are not necessarily only the output. So there's different packages that extend RMarkdown through the YAML header. There's the Glosario project, which is a project that I worked on with Greg Wilson and Francois Michonneau from the Carpentries, that allows you to define things and different terms across data science in RMarkdown documents. So let's say that you're building a lesson and you want to say, hey, this lesson defines these terms. These are the terms that I want. These are the terms that I want listed at the end with their definitions. I'm going to link through them throughout the lesson. Glosario allows you to do that. But there's also other packages like lambdr that allow you to use AWS Lambdas to use RMarkdown documents through something called parameterized documents. And that allows you to run those RMarkdown documents as if it were a Lambda function. So it's quite extensible. The last one that I wanted to mention is xaringan. And xaringan is actually the framework that I use to make these slides and this presentation. So yeah, it's very flexible for what you can use RMarkdown. You can use multiple languages. So yeah, that's what I wanted to share. And if you want to know more about RMarkdown, this is a really good book. It's called RMarkdown, the Definitive Guide. And it covers everything: how to do HTML pages, how to do blogs, how to do books, how to do PDF reports, how to do interactive reports. All of that is covered in this book. So if you're interested in RMarkdown, I would recommend for you to look at. It's free on the web, but there's also the printed version by CRC Press. Now, there's also another new option that it's coming out soon, and that's called Quarto. And Quarto, the way it works is that it's a language agnostic publishing system. And the thing with our Markdown is that it's tied directly to this package that I mentioned called Knitr. And Quarto sort of still supports the Knitr as one of the options, but it aims to go beyond that. So it also supports Jupyter notebooks, and it supports ObservableJS environments, so that you can have, if you want to have one document that has Jupyter notebooks and use a Jupyter kernel, but write it in Markdown and have it be an interface similar to the one that we were seeing before with our Markdown, that you can do so that way. Now, I wouldn't, even though it sounds really cool and it has out-of-the-box support for books, blogs, etc., it's still under heavy development. So I wouldn't go and try it. Like I would try it out right now, but I wouldn't use it for anything that needs to be production ready yet. Now, the other package that I want to talk about is Shiny. And Shiny, it's a package that allows you to build web applications within R. Shiny is quite useful and quite known in the R community because it allows you to build really pretty web pages like this one that I'm showing here. It's an application that allows you to see data, that allows you to examine data from the 2014 elections in Brazil. But there's also other pages, like you can do this more as a dashboard to examine data. You can do it as an interactive application to take input forms or to do surveys. Like there's a bunch of examples of things that you can do with Shiny. And the nice thing about it is that you don't need to know any HTML or CSS or JavaScript to configure any of this. You just need to know a little bit of R code and you can have a Shiny application up and running. Yeah. So you might be thinking, hey, yeah, Shiny sounds cool, but I know how to do dashboards with other frameworks in Python. And yeah, that's right. There are other frameworks in Python that do exist. So the way that I want to first explain the Shiny reactivity framework is that whenever you have an input, there's a computation that is going to be done on that input. And then there's an output that it's going to reflect what's done with that input. That Shiny takes all of those inputs and all of those outputs and computations and builds this graph, which is the reactivity graph. So that once you change this input, this fires this whole pipeline and these two outputs will change. Now, with other frameworks, like with Streamlit, that doesn't happen. With Streamlit, when you have reactivity, when you change something in the application, it's going to run the whole script again. So it's going to run everything from the beginning again. And that makes things a little bit more tricky to handle when you want applications to have a lot of inputs and a lot of reactivity at the same time. Now, there's other frameworks like Dash and like Voila. And the thing with Dash, for example, is that it has external dependencies like with React.js. So if you want to do certain things beyond what comes out of the box, you've got to dive a little bit deeper into React. And that's cool if you know JavaScript because it opens a whole world of possibilities. But if you're not as familiar as with JavaScript, it can be a little bit daunting. Now, the last one that I wanted to talk, it's Voila. And Voila is quite cool because it allows you to use widgets within your Jupyter notebook. But that's the same thing that limits it a little bit. It's that it depends on being run on a notebook and being coded on a notebook. So if you want to know more about Shiny, how all of this reactivity works, how to build apps, how to build reports, what's the difference between what to consider for a report and for a dashboard and an app, this is the book to read. It's called Mastering Shiny, and it's written by Hadley Wickham. So with that being covered, you've gotten a primer of how to access data with both Python and R. And now you know how to present that data with R. So you know how to do a report, you know how to do a Shiny application, or at least you know the packages to do so. And you know of new frameworks that are coming. Now I want to talk to you about tools that I think folks that are Python proficient or that are getting started with Python should know about R. The first one is Reticulate, and Reticulate is quite cool. When it came out around 3 years ago. And it's because it provides an interface for that you, within an R session, you can interact with Python code. And the most basic example that I could do is this one. It's you load the library Reticulate, this is R code, and you're importing here the OS package, the one that comes with the system library of Python, with the standard library. And you import that package. And if you want to access any function within the package, you just use the $sign and you access the package. So in this case, we're just listing the directory, seeing what are the things that are in this directory, and it's returning that information as an R vector. So if I want to do further manipulation with that in R, I can do so. And this is quite nice because it reduces the barrier to entry to R. You can still implement things that you know in the Python world that work, and sort of just translate them to R at first, see how that executes, and then start moving slowly towards more R-centric code. So yeah, this is how it works. Reticulate is not only limited to this way, you can also execute full scripts and so on. And yeah, it calls Python from within R. You can translate between R and Python objects. So if you have, for example, a pandas data frame, it's going to be translated to an R data frame so that you can use it in your analysis as well. So you can imagine how that is useful. You can do a certain data wrangling step that it's quite hard to do in Python. You can do it in R and then keep doing all of the rest of your analysis in Python, or vice versa. Now, it also has support for different versions of Python. So you can use virtual environments, you can use Conda environments to support it. So you don't have to stray far away from what you already know. The other tool that I think you should be familiar with in R, it's called Target. And if you're familiar with Make, or if you're not familiar with Make, Make is a tool that allows you to build pipelines within a specific environment. So if you want to say, hey, I have this input and I have this output, and these are the steps that I'm doing in between, it allows you to not have to run the whole pipeline all the time if not all of the inputs have been changed. So targets bring that same thought into the R world. And for example, here we start with a data biomarker, and the data biomarker, it says, hey, it's up to date. Now we can see that there's 2 models that are going to be being trained based on this input. And that one is for albumin, the other one is for bilirubin. And we can see that this process has already started training, but this one is outdated. So we know that these nodes still have to run so that we get our recent updated plot. But we know that once this runs, we don't have to, if we were to rerun the whole pipeline again, we wouldn't need to train this model again because it's already been trained. So that's the sort of things that work with targets. If you're doing a complex pipeline, it helps to manage all of the dependencies that there might be across the files. Now, the other tool that I want you to know about, it's the tidyverse. And the tidyverse is not as much as a specific tool, as much as a whole universe of packages that have been designed. And the tidyverse is quite nice because it provides a uniform interface for how to access data with different packages, and it sort of unifies things into a tabular data so that you can, with following tabular data, you can implement things in R more easily using verbs. So these are the core packages. There's packages to read data, to clean data, manipulate it, visualize it, to do functional programming, to do strings manipulation. There's the table package, which is the one that is central to provide the data structures. And there's the forcats package to provide factor manipulation. Now, you might be thinking, hey, this sounds a little bit familiar to the SciPy stack. And that's true, it does sound similar to the SciPy stack. Although there's not a one-to-one relationship, because there's things, for example, like images that you can deal very easily with the SciPy stack that are not yet first-class citizens within the tidyverse. So those things, they're not a one-to-one relationship, but it's helpful to think about them as universe or ecosystem that aim to support data science in both languages. Now, there are similarities across language ecosystems, and the first one is virtual environment. In R, we have this package called renv, which is very similar to the virtual env package, and to the venv package in Python. Within an R session with renv, you would initiate your project library. So this is saying, hey, I'm gonna initiate this project library. I'm gonna store every package that I install. I'm gonna install it here in this project library and not globally on my computer. Then if you wanna save the state of the project so that you can save it to an rm.log so that you can later restore the project, you just run rm snapshot and you restore your virtual environment. And you take a snapshot of the virtual environment. Now, if you want to restore the state of the project library, you just have to have this rm.log file available in your computer, and it will restore that project library. This is quite useful if, for example, you're aiming to use CI/CD systems and so on, because you don't have to be installing or keeping track manually of all of the packages that are being used. You just use renv as a dependency to install and uninstall all of those packages that might be needed. Now, in Python, it's very similar as well. You call Python and then you create a virtual environment. In this case, we're calling it the demo environment. You activate that environment. This is a step that needs to be done manually every time you're going to use the environment. And then you can take snapshots of the environment as you did with R, and you can restore the state of the environment as you did with R as well. So very similar over there. Now, there's also similarities across the language ecosystem with the class systems. In R, you can use the R6 package to define an R6 class. In this case, we're defining a class of a person, and we're saying, hey, it has a name, it has an age. We're going to initialize this. So what this means is whenever a class is created, so whenever an object is created, that is object of class person, they have to give us a name and an age so that we can assign that. And then there's going to be a birthday function that whenever it's called, it's just going to update the age by 1 year, which is what happens in all of our birthdays. In Python, that would do something like this. So you would have your class person, you would have your initialization, so self.name equals age, self.age equals age. And then you would have also your birthday function being passed as self object so that it can be updated, so self.age, and yeah. That's how you do it in Python. So it's fairly similar. In R, a little bit more verbose than in Python, but the concepts are translatable across one another. Now, I've shown you a lot of really good things and cool things about R, but it does have some limitations. The first one that I encounter a lot usually is that most software development kits are not available in R. So if you go looking for a software development kit for AWS, for example, how do I make connections to AWS and those things, they don't exist. That doesn't mean that there are not packages to make connections, but they don't exist. The other thing is that event-based architectures are not usually supported by R packages. So if you have a package that, for example, if you have an architecture that, for example, receives a message and then that script needs to run and so on, that is not usually, or at least I haven't usually seen it in the R world. So it's not as common or as supported as in other languages. And lastly, it's cran. And cran, it's the package repository where all our packages go to live. And cran is both an asset and a liability from my perspective. It's an asset because it standardizes all of the packages that we have in the R world. And it makes some quality checks so that they're uniform and that they can be installed across different systems. Now, it's a liability because it's mostly volunteer run and it's not as properly funded as PyPI. So things like security, for example, are not as prioritized as in other package repositories. They're also not as much as a concern, so that's also good to know. Now, it's different from PyPI in the sense that in PyPI, I can go right now and create a new package, and as long as the name is not taken, that package is mine and folks can install from it. In cran, it's not like that. Your package has to have like a purpose, and you've got to submit it to cran for evaluation. So they're going to perform some checks on the test, on the documentation. They're going to ensure that the package can be installed, that all the dependencies match, and so on. And if all of those tests pass, then you can have your package up in cran. So the barrier of entry to have a package in cran versus in PyPI, it's a little bit higher in CRAN. Now, that doesn't mean that there are not alternatives to host your R packages. If you're looking for an open source self-hosted solution, you can have a DRAT repository, which is another R package that allows you to create a package repository for R. You can have a commercial product like RStudio Package Manager, which is a product that my company develops to help you address some of these issues. And then there's the R universe, which is sort of a more federated solution in which each package R author can publish their own packages and folks can just install from there. Now, I mentioned before that there aren't those many software development kits to work with R in the cloud, but that doesn't mean that there are not packages to work with R in the cloud. The CloudDR project has a bunch of packages, and if you search it like that in Google, like CloudDR, you will find a page that has all of the packages to do things with storage, with compute, with serverless services, and so on, in the different cloud providers. So it aims to provide support for AWS, Azure, and Google Cloud services, but there are also other packages that allow you to do things with, for example, DigitalOcean. Now, lastly but not least, I want to talk about the case study, the data pipeline, and this will sort of incorporate all of what we've seen today into one picture. So the first thing is to look at the problem. In this case, it would be, we want to solve the problem of predicting the number of smoke shops in a given zip code in the state of New York, based on median age and average household size on that zip code. So this is the problem. This is the problem definition. And this is usually where I like to get started with my problems. If you have a problem definition like this, it's fairly easier to get started than if you don't have a problem definition. And that's usually the tricky part of being a data analyst or a data scientist, is that we usually don't get these problem definitions like this. We have to sort of define them ourselves by talking with our stakeholders and managing those relationships and seeing what their expectations are to be able to define the problem that we want to solve. Now that I know the problem that I want to solve, I lay it out into the different steps. So I need to get census data to get that median age and average household size info per zip code. I need to get the smoke shop data. I need to train the model that is going to make those predictions. I need to serve those model predictions so they can be consumed by someone. And I need to present the model output to the end users. So if you want to see this pipeline, it's available here at this link. And yeah, you can look at the code there and at the solution and the diagrams and so on. So I want to divide this into how can I address this with the best tools possible to do it and the most efficient based on my skills. So the way that I would do it is I would get the census data and the smoke shop data using R. And this is because there are specific packages in R that allow me to access this data a little bit easier than having to use APIs. So I would use the tidy census package to get the census data from R, and I would use the R Socrata package to get the smoke shop data from the New York Health Department. Then I would train the model to predict with Python using scikit-learn, and I would serve those model predictions also using Python with FastAPI. Lastly, I would present the model output to the end users using R and using the Shiny package. How that looks in terms of like the actual pipeline laid out, it's this diagram that we have here. So this is the first script that, and the arrow, what these solid arrows mean is the way that data is flowing. So what this R script does is it downloads the census data and it stores it in an S3 bucket. The second script, it downloads the smoke shop data from the health department and it also stores it in the S3 bucket. The Python script will get that data and get it into its environment and train the machine learning model with that data. And then it saves that model back into the S3 bucket. Then this other service, which is the FastAPI one, it's gonna download that model from the S3 bucket and it's gonna serve it using FastAPI. And lastly, this R script is gonna be the one that has the Shiny application, and it's actually going to fetch the predictions from the API and present them to users. So when you say, hey, I've got a neighborhood that has a median age of 40 and it has an average household size of 3, what's the number of smoke shops that are going to be there? So that would be the whole pipeline. And I know that you can do this all in one language and you can do so all in one script. The thing is, it doesn't scale if you do it that way. So let's say, for example, your smoke shop data gets really, really big. You wouldn't want to have your whole pipeline have to scale up just because one step of the pipeline it's having more needs. So with this way, you would be able to, just for this script, assign it more resources so that it can execute independently and serve that data into the S3 bucket. The same thing with the machine learning and so on. Now, this pipeline, I sort of did it with some things that can be improved. Sort of that if you want to take it as practice, that you can do so after the talk. So all of the R config values, there are some that are right now hard-coded. You can improve that using the config package in R. So if you want to start by just changing configuration values in R to get your feet wet with that, you can do so. You can do more complex things like normalize the number of smoke shops and store this as metadata to be used later post-prediction, so that it's more, to see if it improves the performance of the model. You can add RNs and virtualns for the different components of the pipeline. You can add versioning, you can add login, you can Dockerize things, and you can extend the Shiny application to show more information, like the whole census data for that zip code, even if the model is using only 2 variables. So these are all things that you can do to sort of try and test things out based on the talk that I gave today. And yeah, that's mainly what I wanted to talk to you about today. Thank you for joining the call, and apologies for all of the hiccup with the platforms.
If anybody has any questions, feel free to post them in the chat. This was a really great presentation, and there are a lot of great takeaways comparing R and Python. I was especially excited to see scikit-learn in there, so it's nice to be able to access scikit-learn from R.
Yeah, that's something that we sometimes see because there's some, for example, some functions that are only available in Python that are not available in R. So in R, we have the tidy models package, which is similar to scikit-learn, but it's not the same, like it doesn't have the full functionality. So there are other things as well, like third-party packages, like, for example, graph2vec. It's an algorithm that it's only available in Python. It's not available in R. So if you wanted to do things with that algorithm in R, you would have to use something like reticulate.
I just posted the link to the slides in the chat, so you have them. Yeah, if anybody has any questions, feel free to, you can post in the chat, or you can share your microphone and camera as well. So there is a question. It says, is it advisable to work with R and Python? I guess the question is together.
I would say so. Yeah, if it's possible, or if you want to start doing it because if it's of interest, then yeah, I would do so if possible. The one thing to be wary of is not to try and force Pythonic patterns, for example, in your R code or vice versa. So be aware of things that are mostly done in Python, things that are mostly done in R, and try to respect that within your code, because if not, things are gonna get a little bit trickier.
I have a question related to the versions of different libraries. When, say, within R, you use Articulate to use Python, do you specify like the version of the library that you'll use?
So the recommended way to do that would be to set up a virtual environment and then tell to Reticulate, this is the virtual environment that I'm going to use, and that way you have your versions pinned down as you would regularly do in a virtual environment.
So someone has a question that says, how efficient is it to use packages as reticulate to work with both Python and R in the same document? Yeah, what are your thoughts on that?
So it's quite efficient. I've done it a couple of times. There's not like a performance bottleneck or anything like that between translating between objects, if that's one of the worries. So yeah, it works quite well. For example, the R TensorFlow package, it's a reticulate wrapper around the TensorFlow Python package. So if you look at the code, it's mainly just a wrapper around the Python code. It's not like the functions were implemented from zero or anything like that.
Next question is, I see you use FastAPI for machine learning in R. So is it good to use FastAPI in machine? I guess the question is, maybe it's the way it's stated in Python. So do you use it in R as well, or it's really just for Python?
So FastAPI you can only use in Python, as far as I know. But the thing that you can do is you can implement like an RMarkdown document or a Shiny application that reaches to that FastAPI to get the data, and then you have it within your R environment.
I have a question, which is, in your work, how, for people who use Reticulate, what are commonly accessed Python libraries within R via Reticulate?
I've mostly seen machine learning libraries like scikit-learn and so on. I haven't seen much aside from that, to be honest. But yeah, sometimes certain things patterns that I've seen as well is that there are libraries, specific libraries to do genomic analysis within Python or within R, and folks will divide their pipeline to use the best library in Python for one step and then the other one in R, and so on, because R, for example, has support for bioconductor, which is an optimized package repository to do bioinformatics. So yeah, there's really a lot of, like, the main takeaway for me would be that there's really a lot of possibility when you join the both languages instead of thinking about them as one or the other. If you think about them as which has the best tool for this specific step that I need to accomplish my task, and then sort of work with implementing them together, it would be best.
So as someone who's particularly interested in scikit-learn, what is it, because I have used R, I actually learned R first quite a while ago, but I use Python more now, is what does scikit-learn offer that isn't available in R?
Right, so in R, you have the Caret package, which is an old machine learning package. And more recently, you have the tidy models package, which aims to accomplish what the scikit-learn does. But that uniform interface that scikit-learn provided of like having all of the estimators with regression, classification, so on, like so uniformly defined, it's not as commonly seen in the R world. So most folks will sort of use that to use the scikit-learn and have that common interface to like the estimators and do things like the grid search, cross-validation, and so on using the tools from Python. And then import those results back into R, just because it's easier and they know it. Like, for example, myself, I wouldn't know how to do it, or at least off the top of my head, I know how to do a grid search cross-validation in scikit-learn in Python, but I don't know how to do it in R, even though I've been coding in R for longer. So I would do it. I would do that reticulate pattern that we just talked about.
Oh, great. Yeah, scikit-learn definitely has a very good reputation for a very robust and consistent API, right?
Yeah.
Right. Okay, great. Does anybody else, if you have any questions, feel free to post in the chat, or as I said, you can share your mic and camera if you wish. I guess the other question that I have for you, Ian, is how much do you use Python and R?
I use both. More lately, I use Python, and I've been getting my feet wet with Go, just because I've been doing more infrastructure work. But still, when I have to do a report or, for example, this presentation, I did it using RMarkdown. So just to not get rusty with R.
Okay, great. And I have one more question is, oftentimes I hear people say that R is really, really good, but one of the things that maybe that doesn't exist in R, and maybe, you know, you can clarify it, is that maybe it's not the best option for really large data sets and some things in production. This is something I hear often.
Yeah, I think that's a common misconception a little bit. And it's based just on the way that you write your code. Like, essentially, there's things that in R you've got to do a little bit more different than in Python. For example, with for loops and vector allocation and memory allocation and so on. But it's not that it's wrong. It's not that it's just or more inefficient. It's just that it's different the way that you've got to do it. So yeah, and sometimes folks, I think, like, based on their not fully understanding the tools, might say comments like that. Now, yeah, you can have productionized R code, and we see it all of the time. Like, you can run Spark jobs using R. You can run things in Kubernetes using R. Like, there's the futures package that allows you to incorporate things with HPC clusters. So there's definitely like an array of tools that allows you to productionize your R code and scale it up and horizontally as well as much as you want to.
Great, thank you. And there are no more questions, so I'll just sort of ask a general question. Is you currently work at RStudio, right?
Yeah.
Do you just want to talk a little bit about RStudio, what it is, what you do there?
Yeah, sure. So RStudio is a company that develops data science software. So it develops three main products. The first one, it's called RStudio Workbench. And that's a development platform. It allows you to do both R and Python work in the cloud using the RStudio IDE, which is an IDE that we build in the company, but also using Jupyter Lab, Jupyter Notebooks, and VS Code. And the idea is that you have all of this within your infrastructure, and you can scale it out using things like Kubernetes or Slurm to run your R sessions. Then there's another product called RStudio Connect that allows you to host things like APIs, Shiny applications, and so on. And that's sort of like the production platform. You can have that hosted in Kubernetes. You can have that hosted in AWS, like anywhere that you want to host it. And lastly, there's RStudio Package Manager that allows you to have all of your package repositories, so that if you have private Git packages and so on, you can have them in a centralized place. So yeah, those are the products that the company sells and builds. And there's the open source part of things, which is 50% of the company efforts go toward open source efforts. And those are things like the tidyverse that we saw, things like Shiny, like RMarkdown, are mainly developed by RStudio. But they're free open source packages that you don't need to buy anything from RStudio to use. Yeah, and within that, I'm a solutions engineer, and I mostly help folks with their deployments to the cloud. So whenever they want to install RStudio, let's say RStudio Workbench and RStudio Connect using Kubernetes in the cloud, and they're going to use R and Python, and they need help with the virtual environments, that's when I come in and I help them set up that part. So yeah, I really enjoy it, getting to talk with a lot of folks and seeing different data science environments all day, and different patterns as well of deployment, of management, version control, and so on.
Great, thank you. And I have, you know, if we're out of time, it's okay, you can let me know. But I was wondering, are you able to share what the, you know, I've used R before, so I'm very familiar with the environment, I guess the IDE. Are you able to sort of screen share the development environment and show people what that looks like? The reason I say that is I think that one of the real strengths of R compared to Python is that, you know, there is that standard IDE that exists where you can see the code, you can see the log, you can see the output. And it's a really, you know, it's a really friendly, helpful way for people to use R and learn R.
Yeah. Let me pull it up on my screen. I'm loading the product.
Sure.
Okay, so this is the RStudio Workbench product. It allows you to have different sessions, and I'm just gonna open one of the sessions. This is what Reshama was talking about. This is the RStudio IDE, and comes with the primary support for R, but it also has support for Python. And essentially, you have this IDE here, your code here in this left-hand side, and here you have your console. You can execute the code, but you can also run the application. So in this case, this is how you would define a Shiny application, and you have it here on your right-hand side, and you can interact with it, and it will change the output. It's nice because it allows you here to have different environment variables, and all of your variables that you have in the environment. You can see your history of commands. It allows you to see connections that you might have to databases. So if you have a Postgres database, if you have a PIN, which is sort of similar to cloud storage, but within R, and you can also say that in cloud storage. You can see it here in the connections page, and you can have tutorials. So if you want to follow a specific tutorial, you can do so as well with this tutorial pane. So it really allows you to work with R more flexibly than if you were to do it from the terminal and just execute a script, because you can do interactive things.
That's great. Thank you. I don't think last time I've used R that I saw the tutorial tab. So is that kind of new, at least within the last few years, or?
Yeah, that's kind of new, I would say, within the last 2 to 3 years, as well as Reticulate. And the idea is that you can use RMarkdown and Shiny to build those tutorials. And if you want to walk folks through building exercises within the same IDE, they don't have to be using a separate browser to have like all their documentation and so on. You can have everything within the same IDE window.
All right, that's cool. And I guess one last thing that I would say is, can you just show people where to go to download the R IDE if they want to try it out?
Search it up.
And a question, because it's been a little bit of time, do you have to install R first and then RStudio?
Yeah, you do. You have to install R first. The instructions will vary on your operating system, but you come here, this is the rstudio.com page. You come here, download the RStudio IDE, and for your own computer, you would choose the RStudio desktop, the open source version that it's free here. And you would click download, and it will recognize your operating system so that you can download the link specific to your operating system. But if you want to download for other operating systems, you can do so as well. So here it says, hey, install R, and it gives you where to install it, which is going to take you to CRAN. And here you can download R for Linux, download R for Mac, or for Windows.
All right, that is super. I think that is a wonderful place for people to go and get started in R. Yeah. Thank you so much for presenting, and thank you so much for also setting up the Zoom account last minute so we could have our webinar, given that we had a last minute technical glitch. So yeah, thank you so much.
Sure. Thanks for having me, Reshama.